Hi, my name is James Gao, and I'll be going over my Lab 2 on lines of charge. So the purpose of this lab was basically an extension of Lab 1, but I had to use a more complex model in Glowscript. And the main result that I got was I got a larger charge value in Lab 2 that was approximately 260% of the charge I got in Lab 1. So the principles that I used were Coulomb's law, which is this formula, to help find the electric force on the tape as well as the amount of charge on the tape. I also used the formula for electric field as well as the principle of superposition, which is these formulas, to help solve for electric force, since it can also be written as QE. And lastly, I used the formula for gravitational force to help determine the gravitational force on the piece of tape. So now just a really brief overview over the procedures of Lab 1. Since this was back in Lab 1. Anyways, I made U-tape, made some observations, and I tried to make this upper tape float, with the system being the upper tape and the surroundings being the bottom tape and the earth. So using that distance, I was able to calculate the amount of charge on the tape, which was 6.73 times 10 to the negative 9 coulombs. So now into the actual meat of Lab 2, which is mainly just coding. So first I declared my constants, which are all the same as the constants I declared in Lab 1, except the charge is slightly different, it's bigger. I also wrote a method to find the electric field of a given particle at a given observation location. And then using the particle's charge as well as the observation location, I was able to find and return the electric field. Next, using a method that was already given to us, this method helps create a line of charges with n specifying the number of charges in a line. So this top tape runs this method and creates basically a line of charges with there being 69 charges. And this line of charge starts at a y position at tape distance and a length of tape length. And it's the same for bottom tape, except it starts at the origin. So next, using a nested for loop, which is basically already done for us as well, I was able to find E net using superposition, then used E net to find the electric force. And the concept behind this is basically you find the electric field of every bottom charge on every top charge. And then through that, you're able to find the E net at each top charge. And then with that, you're able to calculate the electric force at each top charge. And then you basically add that. And right here, this just basically creates each arrow at each top charge that represents the electric field. So next, this code right here, this just generates the electric field, the electric force vector, and this code right here just generates the gravitational force vector, with it being negative mg in the y direction. And this code right here just prints out some necessary statements. So these are my results. The red line, which is pretty thin, represents the top tape. The blue line right here represents the bottom tape. The green arrows represent the electric field vector at each top charge. The white arrow represents the electric force vector, and the yellow arrow represents the gravitational force vector. And so I get a charge of around 1.753 times 10 to the negative 8 coulombs. And the magnitude of the electric force and gravitational force are equal. So my main sources of error were that I assumed each U-tape had about the same amount of charge and that they were evenly distributed, and I also ignored air resistance. And some similarities and differences between my data and model predictions were that I used the same calculations for both. However, my model, my basically code, assumes that no charge was lost, even though that was not the case probably. So that also contributes to a source of error. So what if I modeled each of my tapes as a single point charge? Then I would get a smaller calculated charge versus a line charge model where I got a charge that was approximately 260% larger. So why do these estimates differ? Because the point charge just takes into consideration of there being one charge, whereas the line charge model has multiple charges. Which value is more likely to be closer? Well, then it's the line charge model, since on the piece of tape, there's not only one charge, there's a lot of charges, and it's most likely that they're all spread out, which represents the line charge model, which more closely aligns with the line charge model.